Okay, so let's have a look at this one. We got this brittle material, 2 diameter bar mounted to the wall. It's got, so the ultimate strengths there are 20 ksi in tension, 30 ksi in compression. And what we want to do is we want to have a bending moment applied to the end as well as a torque, both of them with the same magnitude. And then we're going to use the maximum normal stress theory to find the largest value of M for which that won't break it. And then we're going to test if we would expect failure according to the Mohr's Coulomb theory of failure if that same moment was applied. So yeah, a couple things. So the diameter is 2 inches, so the radius is 1 inch. So our J is pi over 2 times 1 inch to the fourth, so 1.57 inches to the fourth. I is half of that, 0.785 inches to the fourth, which gives us our shear stress. So shear stress due to the torsion, again, at the outside, that's going to be based upon the torque and the radius and the J. So M times the 1 inch divided by the 1.57 inches to the fourth gives us 0.6369 M per inches to the third. Our bending stress, so bending stress, again, depending on what location we pick, but the maximum values are going to be plus or minus M times Y over I. So M times 1 inch divided by the 0.785 inches to the third. That gives us 1.33 inches, 1.33 per inch third times M. So we're going to use the tensile one because that's when we have the worst case scenario. So our little stress element looks like this. We got 1.33 per inch, per inch third times M tensile stress, and then the shear stress is 0.6369 times M per inch third. So the average normal, the average of the x and the y stresses is just the x stress divided by 2, so 0.666 M, and then our R here, that ends up being based upon the difference between this and this, which since the other one was 0, just ends up being the 0.666 M squared plus the 0.6369 M squared. So we are able to find that our R needs to be equal to 0.922 M. 0.922 per inch cubed M. So we can solve for our principal stresses as this, the first principal stress is just our average here plus this. That works out to be 1.58 M per inch cubed. And then the second principal stress is just this minus this, which gives us negative 0.256 per inch cubed M. So if we're basing this upon the maximum principal stress theory, this one's the largest. So so basically we're going to have failure occur when 20 ksi is equal to that. So we can solve for M, and that ends up being 12.66 kip inches. So the second part of the question, is this still safe if we use the Mohr's Coulomb safety criteria? So we just draw a Mohr's circle for the compressive failure criteria, and we draw a Mohr's circle for the tensile failure criteria. And we'll assume I'm able to draw a circle. And then we draw a line kind of between the two. So that's our safety envelope. So any Mohr's circle for the stress state that we calculate needs to fit within here in order for our condition to be met, in order for it to be safe. So what is the Mohr circle for this situation? Again, we know what our moment is, and we know what our the center of the circles are based upon the moment. 1.666 m per inch third times when we plug the 12.66 pound inches into m, that gives us, oh sorry, that's not pound inches, that's kip inches. So that gives us 8.43 ksi, and then our radius similarly 0.922 per inch third m. Plugging in that value for m, we get 11.67 ksi. So when we plot that on here, I'm gonna make that bigger. I plot that on here. It's got a center here, and it looks like about that. So basically, it's meeting at the same point right here, right at this point, but because its radius is larger, because it's meeting at the same point at the very far end, but since its radius is larger, because its center is a bit to the left of the center of the circle for the 20 ksi tensile test, the rest of it is outside that safety envelope until we get to it there. So this thing is going to, we do expect failure to occur based upon the Mohr's Coulomb criteria, as opposed to the maximum principal stress. So two different failure criterias. One of them not predicting fail. One of them predicting failure basically before the other one does. And yeah, that's about that.